On a warm summer night, you don't need a spotlight to see what's alive. You see it in flashes, small, quiet points of light appearing everywhere at once. Each firefly blinks on its own rhythm. No conductor, no central switch, no tower telling them when to glow. And yet together, they form a living pattern across the dark. Now imagine a storm rolls in. Most of the fireflies scatter, but some remain, blinking steadily in the underbrush. They don't need the whole swarm to keep going. They don't need perfect conditions. They have their own light, their own capacity to persist. This dual image, the coordinated swarm and the resilient individual, captures something essential about building technology that can actually last. We need systems where millions of participants can coordinate effortlessly under normal conditions. But we also need the capability for any individual to verify everything independently and act without permission when things go wrong. Vitalik Buterin, Ethereum's co-founder, calls this second capability the mountain man's cabin. The ability to retreat to complete self-sufficiency when centralized services fail or turn hostile. It's not where you live every day, but it's the fallback that must exist and remain accessible. The cabin represents the technical capacity for independent verification, running your own node, processing your own proofs, maintaining your own sovereignty without relying on anyone else's infrastructure. For years, these seemed like opposing visions. Lightweight participation for everyone, or heavyweight independence for the few. But something remarkable has happened. The tools now exist to have both. We can build systems where lightweight participation is the default, but where the cabin, that capacity for complete independence, remains accessible when needed. This essay explores why that matters and why it changes what we should expect from the internet's future. The old problem. Think about how most of today's internet works. You have massive companies running huge data centers. When you want to do something online, send money, store a file, post a message, you're basically asking permission from whoever runs that server. This creates two problems. First, it's fragile. If the company shuts down, changes its rules, or gets hacked, you're out of luck. Your data, your access, your history, all gone or blocked. Second, it's not really yours. You don't own your account. You don't control your data. You're a guest in someone else's house, and they can change the locks anytime. Early internet visionaries, from cypherpunks to open source pioneers, tried to fix this with something different. Systems where no single company is in charge. Instead of one big server, you'd have thousands of computers working together. No single point of failure. No gatekeeper who can shut you out. But this created its own problem. How do you make sure everyone agrees on what happened? If there's no central authority, how do you know the truth? The evolution of understanding. The first solution was simple but expensive. Make everyone keep track of everything. Your device would need to process and store every transaction, every update, every change, just to stay synchronized with everyone else. This works for security, but it's impossibly heavy. Bitcoin proved you could build a network where no one's in charge, but it came with a cost. Either run a full node and process every transaction since 2009, or trust someone else's version of the blockchain. In practice, only people with powerful servers could really participate fully. Everyone else had to trust those few big operators. We escaped the cage of big tech companies only to recreate it with different gatekeepers. Ethereum tried to evolve beyond this by adding programmability and attempting to make verification lighter, but it still relied on a single shared ledger where everyone competes for space in the next block. The fundamental architecture, one global queue processed sequentially, remained unchanged. Scalability meant either accepting centralization or building increasingly complex Layer 2 workarounds. Vitalik Buterin, co-founder of Ethereum and one of the most influential thinkers in blockchain technology, traced this exact evolution in his own thinking. In 2017, he argued that blockchains must commit to state, account balances, smart contract data, in their block headers, not just transaction order. Without state commitments, users would either need to process every transaction in history themselves or blindly trust someone else's version of reality. But by early 2026, Buterin publicly reversed his position. What changed? The breakthrough. Two things changed that make a new approach possible. First, the technology got smarter. New mathematical techniques, particularly zero-knowledge proofs or ZK SNARKs, cryptographic proofs that verify computation without revealing underlying data, let you prove something is true without showing all the underlying data. Applied to blockchain systems, this means you can verify that everything is legitimate without processing every single transaction yourself. The verification is lightweight. Your phone can do it. As Buterin put it, we now have a technology that lets you verify the correctness of the chain without literally re-executing every transaction. We invented the thing that gets you the benefits without the costs. Second, reality taught hard lessons. Buterin's shift wasn't just about technology. It came from observing what actually breaks. In the real world, lots of things break. Sometimes the P2P network goes down. Sometimes intermediaries all start censoring some application, and your only option becomes to directly use the chain. You don't need to verify everything every day. But when companies fail, when services get censored, when platforms change their rules against you, you need the ability to verify everything yourself and act independently. The mountain man's cabin. This is where Buterin introduced a powerful metaphor that perfectly complements our Firefly vision. The mountain man's cabin is not meant as the replacement lifestyle for everyone. It is meant as the safe place to retreat to when things go wrong. The cabin isn't where you live every day. It's your guarantee of independence. The place you can go when everything else fails. It's also your leverage. The option that improves your position, not just when you use it, but because others know it exists. This reframes the entire debate. We're not choosing between lightweight participation and heavyweight independence. We're building systems where both exist simultaneously, where the Fireflies coordinate efficiently under normal conditions, but where the cabin remains accessible when storms arrive. The Firefly vision. Here's where it gets interesting. What if instead of everyone competing to write to one giant shared database, each device simply kept its own record? Your phone has its record. Your laptop has its record. A sensor has its record. When your device does something, sends a payment, stores a file, records data, it doesn't wait in line for permission to write to some global ledger. It just updates its own history. This fundamentally changes how participation works. It's lightweight. Your device only needs to know its own past, not everyone else's. It's immediate. You're not competing with millions of others for space in the next block. It's resilient. Your record exists independently. Of course, independent records still need to be coordinated. You can't have everyone claiming different things happened. But here's the elegant part, that coordination can happen after the fact, not in real time. Think of it like email. You can write and send a message immediately. Your action is local and instant. Later, mail servers coordinate to deliver it globally. You don't wait for global permission before hitting send. The global coordination happens asynchronously, in the background, invisibly. This architecture, dual ledgers where each participant maintains their own chain while a separate layer handles global ordering, is what makes both the Fireflies and the cabin possible. Without it, you face a brutal trade-off, either sacrifice throughput by forcing everything through a single sequential bottleneck, reducing capacity by orders of magnitude, or sacrifice sovereignty by pushing users onto trusted intermediaries. The dual ledger design breaks this trade-off entirely. The key shift is separating local causality from global ordering, letting your device act immediately based on what it knows, while a separate process sorts out the global timeline. It's a fundamental departure from both Bitcoin's UTXO model, where unspent transaction outputs form the ledger state, and Ethereum's account-based single ledger, taking Bitcoin's vision of individual sovereignty and combining it with the programmability Ethereum introduced. but without either system's architectural constraints. Yes, this creates temporary inconsistencies, brief moments where different participants might see slightly different global states before consensus resolves. But in practice, these resolve within seconds for most applications, far faster than traditional payment settlement or even credit card authorization. And crucially, ZK proofs can verify that these inconsistencies resolve correctly and provably, which is far better than the permanent bottlenecks and exclusion created by single ledger architectures. For high-stakes applications like financial transfers, the system can require additional confirmations before finality, exactly like Bitcoin, but with dramatically better baseline performance. Devices stay simple, lightweight. The heavy lifting of sorting out the global timeline happens separately through a meta-consensus layer, a higher-level coordination mechanism that resolves conflicts between individual chains. And when needed, you can verify the whole thing yourself using those new mathematical proofs without having to process every single transaction. In practice, these ideas aren't merely theoretical. Networks like Zenon's network of momentum are already demonstrating this architecture in operation. Each participant maintains its own account chain, its own history, without waiting for global permission. Activity is immediate and personal by default, while global ordering happens separately, asynchronously, and verifiably through a meta-consensus layer. The dual ledger design means participation stays lightweight for everyday use, but the capability for complete independent verification never disappears. No leader shouting instructions, no central server deciding who goes first, no single point where power concentrates, just many small lights, each maintaining its own truth, coordinated after the fact. This isn't an incremental improvement, it's a different paradigm, one that could only exist after we learned the hard lessons from Bitcoin's limited throughput and Ethereum's congestion problems. The cost problem. There's one more piece needed. How do you prevent spam and abuse without making participation expensive? Most current systems use fees. Want to send a transaction? Pay up. Supply and demand set the price, which means during busy times, costs spike. People get priced out. For systems designed around universal participation, this is a deal breaker. If your weather sensor has to worry about price surges, it's not really a full participant. It's a supplicant hoping for favorable market conditions. Some networks have abandoned fee markets entirely. Instead of bidding wars, capacity is allocated through resources that regenerate over time, closer to bandwidth or energy than money. This means devices can act predictably even during stress, without being priced out at the exact moment independence matters most. Why this matters? The difference between centralized and distributed systems isn't just philosophical. It's about what happens as they grow. Centralized systems scale by getting bigger. More users means bigger servers, more employees, more infrastructure. The center becomes a bottleneck, then a target, then a point of failure. Distributed systems should scale by getting smaller. More participants doesn't mean any single machine has to grow. But here's what's crucial. Without the dual ledger architecture, decentralized systems can't actually scale this way. Traditional single ledger blockchains force every participant to process the same global state transitions in the same order, creating an unavoidable sequential bottleneck. Adding more nodes doesn't increase throughput. You just get more validators doing redundant work. The dual ledger breaks this fundamental limitation. Because each participant maintains their own chain, adding more participants genuinely increases total network capacity. 1,000 fireflies don't need a brighter sun. 1,000,000 fireflies don't need a bigger tower, they just need room to exist. And here's the critical part. Having the option for independence keeps the system honest. When power tries to concentrate, and it will because economic forces push toward consolidation, individuals retain the ability to verify independently and act without permission. As Buterin warned, if we are making a self-sovereign blockchain to last through the ages, the answer to the above conundrums cannot always be called the devs. If it is, the devs themselves become the point of centralization. You don't need to use that capability every day, but it needs to exist and be accessible. What it feels like. Imagine using a system built this way. You open an app on your phone. It doesn't wait for some distant server to respond. It doesn't check if you have permission. It doesn't worry about network conditions or whether the company's infrastructure is online. Your action is recorded immediately on your device. Done. Later, maybe seconds, maybe minutes, your device coordinates with others in the background. Global consensus happens asynchronously, quietly, without you having to think about it, like email syncing, like messages delivering, invisible infrastructure doing its job. Most days, you never think about verification or independence. The system just works, lightweight, fast, predictable. But then something changes. Maybe a service you relied on shuts down. Maybe a platform bans your account. Maybe you need to prove something that everyone else denies. You don't panic, you don't scramble. You already have your complete history locally, verifiably yours. You can prove what happened. You can act independently. The cabin was there all along. This is the difference between systems that work for you and systems you work within. It's the difference between digital tools and digital landlords. A different future. For decades, the internet moved towards centralization because coordination was hard and powerful computers were expensive. Today, computing power is everywhere. In your pocket, in your car, in your home. Coordination is still hard, but we now have better tools to solve it. The future internet likely won't be built around a few massive data centers doing everything, but around countless small devices doing something real, locally, and verifiably. A weather sensor on a farm, a medical device in a clinic, a local energy monitor, your personal files on your laptop, your financial records on your phone. Each can speak, be verified, and exist without asking anyone's permission. They don't need to shine constantly. They just need to blink when it matters. And when things go wrong, when storms come, when services fail, when platforms block you, each device retains the capacity to independently verify its world and act without relying on anyone else's infrastructure. This is the synthesis that makes both visions work. The Fireflies provide everyday participation, accessible and lightweight enough for billions of devices. The cabin provides the fallback guarantee that participation could become fully independent if needed. Neither is sufficient alone. Together they create something genuinely new. We do not need to start living every day in the mountain man's cabin, Buterin concluded, but part of maintaining the infinite garden of Ethereum is certainly keeping the cabin well maintained. The same principle that applies to any system meant to outlast individual companies, governments, or technologies. Why this matters now. We're living in a moment when this vision isn't just elegant, it's urgent. In 2026, we're watching platforms ban entire communities overnight, cloud providers unilaterally cut off services, and governments worldwide demand backdoors into encrypted systems. AI-generated content floods the internet with no clear provenance. Financial infrastructure fragments along geopolitical lines. The normal conditions where lightweight participation works are becoming less reliable, less predictable, and less neutral. The cabin isn't a luxury anymore. It's becoming necessary infrastructure for a digital world where power concentrates faster than ever, where trust erodes daily, and where the ability to verify truth independently might be the only thing standing between individuals and complete dependence on whoever controls the servers. The internet doesn't have to choose between being lightweight enough for everyone to use and independent enough that no one can control it. With modern tools and, crucially, with architectural innovations like the dual ledger, we can have both. We can build systems where participation is easy under normal conditions, but where anyone can verify everything independently when needed. That combination, the swarm and the cabin, the fireflies and the mountain, is what makes digital independence actually work for real people in the real world. When you look at the world through that lens, not as a problem to be solved by bigger servers, but as an opportunity for genuine distribution backed by genuine independence, It doesn't look like a data center. It looks like a warm summer night with a quiet cabin visible in the distance. And everywhere you look, the world is blinking back at you. Xenon's network of momentum is fully open source and community run. More formal documentation and ongoing community research can be found at github.com.